Friends, let me discuss one numerical on calculation of duct sizes by equal friction method and by using what is known as a friction chart. The question reads like this. We are required to find the duct sizes, and the diagram is given and the layout is given. This is a fan, and for the fan, these are the various sections of the ducts. So the duct is moving from this end. Ducts are moving from to one where 0.75 meter cube of air is delivered. It is going to the section 2 where again 0.75 meter cube per second of air is delivered. Then there is a turn over here and it goes to section 3 where again 0.75 meter cube per second of air is delivered, and finally at 4 again conditioned air of 0.75 meter cube per second is delivered. There is another branch over here, you see, where you find that 0.5 meter cube per second is delivered at 5 and another 0.5 meter cube per second of air is delivered at 6. So in total you will see that it is 0.5 into 2 and 0.75 into 1, 2, 3 and 4. Okay, so this is the total flow rate which is delivered by this fan. It is supplying the conditioned air. And what is asked is, you are supposed to find the size of these ducts. The length of the ducts are given. So this is the length of this section. This is the length of this section, like this. This is the length of this section. So the total length is given. This is D section has a length 2 plus 2, which is 4 meters. E section has a length of 5 meters. B section like this. Okay, so this all the dimensions are given, and you are required to find the friction loss in the longest run. So longest run is 12 plus 11 plus 5 plus 4 plus 5. So this is the longest run, and you are required to find the total friction loss. Okay. What information is with us? Information is that the velocity is also known in the main duct, and that velocity is 7.5 meter per second. It means that this air which is flowing through this duct section, it is flowing with the velocity of 7.5 meter per second. Okay, so how do you solve such kind of numericals? So for finding the duct sizes and the friction loss in the longest run or index run, the first step is to calculate the diameter at the section A. Okay, how do you find the diameter? So you all know that flow rate is cross-sectional area into the velocity. So we will use this relation, cross-sectional area into velocity. This relation will be using for finding the velocity. Okay. For finding the area and hence the diameter of the duct. Okay. So the flow rate at A. What is the flow rate at A? Flow rate at A is the flow rate at 1 plus flow rate at 2 plus flow rate at 3 plus flow rate at 4 plus flow rate at 5 and 6. So if you do the total of this, you will get the total as 4 meter cube per second. Okay, that is the flow rate at A. So this becomes your 4 meter cube per second, and the velocity at A is already given as 7.5 meter per second. Okay, so if you divide this, you will get meter square. Okay, second would cancel, this would cancel with this, and this becomes meter square. So solve this, you will get it is around 0.53 meter square is the cross sectional area. Area of the cross section will assume it as circular cross section. So for that, the diameter, if you want to find, then cross sectional area is pi by 4 d square. So d becomes root of 4 into area upon pi. Again, it's a matter of substitution. If you substitute the values, you will get the diameter as 0.824 meters. Okay, so this is the diameter, right? So the first step is to find the diameter at this section A. Okay. And we are also required to find the friction loss in the total section, longest run. Now friction loss can be calculated from the friction chart, okay, per unit length. We all know that friction charts, we had seen the friction charts, and you know that vertically on the friction chart there is a air volume. If I want to just show it here, friction chart would look like this, somewhat like this, where you will have the flow rate here, and you will have the friction loss here. Okay, friction loss would be here. Friction loss per unit length would be here. Okay, and this would be, there are different units, but maybe we would be provided it in mm of water column, okay, per meter, right? This could be the unit, right? It could also be in some other unit like Pascal per meter and all that. And you also know that for the friction chart, the velocity lines are like this. These are the velocity lines, and we know that the diameter lines are like this. These are the diameter lines. Okay, these are the diameter lines. Okay, so all in all, if you know what is a friction chart, if you know any two parameters, you can calculate the third parameter. Now we know two parameters at the section A, and what are the two parameters at the section A? We have calculated this. This is given 4 meter cube per second. Total we had done for the flow rates, and we have got this 4 meter cube per second as Q, and we have the velocity as 7.5 meter per second. Okay, so using these two, we can find the friction loss in mm per meter cube. Okay, so we will get somewhere here. Let us say, suppose this is your value. Okay, after doing this, suppose this is your 4. Suppose this is your 4, and suppose this velocity, suppose this is just for understanding sake, this is 7.5. So these two intersect and you will get this point, and if you read this corresponding point, you will get the friction loss in mm per meter. So that value is 0.0774 mm of water column per meter. So you have got the friction loss here. Okay. Now in equal friction method, what we'll assume is that the friction loss per unit length throughout the ducts, throughout the duct branches and everything, it remains the same. That is why it is called as the equal friction method. So once you know that there is equal friction method to be followed, so we will keep this friction loss as constant. Okay, this is constant throughout the layout of the duct, right? One other method of calculating the friction loss is by some empirical relation which would be given to you. Okay, so this is an empirical relation we had used, and it is given the problem 0.002268 q raised to 1 point. Q is the flow rate and d is the diameter. We have worked out the diameter, we have the flow rate, and you can find the friction loss per unit length. Okay, you'll get the same value. So now once you get this, we are interested in knowing the total friction loss, and we know the longest duct's length. How much is that longest duct length? So you see that it is 12 plus 11, 23, 23 plus 5, 28, 28, 30, 32, 35, 30, like this. Okay, so this total, if you do, you will get the longest run would be whatever. Okay, so whatever you get, and that if you multiply, here I had got 37 meter. If you multiply that, you will get the friction loss in the index run or longest run. Okay, so this becomes your friction loss in the longest run. So this is how you have to calculate, right? Once you calculate this friction loss in the longest run, so part of the problem is over. You have calculated the friction loss in the longest run. You also are required to find the duct sizes. Now what we had calculated is only the duct size at section A, but we also want to know what is the size at size mean the diameter at B. Similarly, what is the diameter at C? What is the diameter at D? Right? What is the diameter at E? like this. Okay, what is diameter at F? What is diameter at G? So for finding this, again we'll use the same method. We'll use the friction chart method, equal friction method. So for finding B, what you now know is, you know the friction drop. You know the friction drop, right? And you know the flow. Now what is the flow at B? Flow at B would be this flow plus this flow plus this flow plus this flow. So 0.75 into 4, that becomes 3. So flow rate at B, QB, would be 0.75 plus 0.75 plus 0.75 plus 0.75. That becomes 3 meter cube per second. So now you have two parameters. You know this friction rate, okay, and you know this. So knowing this two, you can find the from the friction. Now you know this, and you know the flow rate. Okay, so you know this and you know this, so you can find the corresponding duct size. Okay, so duct size is known. So this is Q and this is the friction drop per unit length. So from the friction chart, you use the friction chart, pause this video, and you can find that the duct size is around 73 centimeter or 0.73 meters. So this way you go on doing it. Okay. For example, again, if I am interested in finding the duct size at B, what is the flow rate? Flow rate would be 0.75 plus 0.75 plus 0.75. So that becomes 2.25. Okay, 2.25. Right. Same friction loss per unit length, because we are finding equal friction method, and we will find the corresponding duct size from the friction chart, which is 66 centimeter. Go on doing this. What we'll have to do is, every time we'll have to find the flow rate at the sections and the corresponding diameter by keeping this constant. So the key point is, the friction rate has to be kept constant. That is why it is called as equal friction method. So I had calculated this diameter for D. You can do yourself. At 3, the flow rate is this meter cube per second, and you will find the diameter as 44 centimeter. At F, what is at F? Look at this. At F, it is 0.5 plus 0.5, that is 1 meter cube per second. Okay, same friction rate, and then you can find from the friction chart the duct size. So if I do that way, so you will see here the diameter is 49 centimeter, and at G 0.5 meter cube per second, diameter is 31 centimeter. So this way we can solve the problem of calculating the friction loss as well as duct sizes, okay, by using the equal friction method.